Hello, it's Duncan with another cold. One of the signs of a good engineer is that they take their own productivity very seriously. Tools can help here, and luckily the tools we need to make better software are often made of software. So if we're good at that, we can find ourselves in a virtuous spiral where we can deliver more per hour rather than less as a project progresses. Kotlin turns out to be a fine language for ad hoc tool building, as you'll see today when we add events to our JUnit test visualization.
That's a fantastic error message. Type variable k found test identifier question mark. We left the last episode with this timing extension, which we can install into any JUnit test run, listening to when tests start and finish, squirreling away the time that happened, and using that to generate a Gantt chart with Mermaid. So that if I run the tests, there they go, we get a chart that looks like this. See, this bar here is our entire test run. That took 1 1/3 seconds by the look of things. Then these sections are the test classes, and these individual bars are the individual tests. And we found that one test, here it is here, DB items test, basically takes the entire test run time. So if we didn't run that, we'd be considerably quicker. But note that it runs in parallel with other tests. So while we're running this one, we're also running this test here, which is in memory items test, and we're also running delete items directly tests. And that happens because we've set some properties in JUnit platform properties that run basically 32 tests in parallel. And when I say tests here, I mean the test classes. Actually, within a class, we run the individual methods serially. That's all controlled by this flag at the top here. If I was to set that to false, let's just have a look at this before we do. Let's do that and then rerun the tests. And our diagram updates, and now you can see that DB items test is run first. This is all the tests in DB items test. They're run serially, and then days 2 test is run, and then after that, standard updating tests, and so on and so on. So the entire test run now takes 2 seconds because we're not running things in parallel. And an interesting thing we can see in this view is that whilst DB items test is the first test at the start, it starts very, very quickly here. The first actual test within that set of tests, this returns empty stock list here, waits for, well, by the look of things, 300 milliseconds or so before it starts to run. That's quite unusual. Normally, the test class starts and then the tests within it start pretty much immediately afterwards. You see that here. Although actually add items test here only has 2 tests, and the first one takes a long time to run after add items test is started. So I'd like to understand what that delay is, and I think maybe a good way of doing that would be to put markers on here at particular times. Now there is a way of adding a marker. It's actually a Gantt chart milestone. So we can say things like marker colon, and then we say that's milestone. Now you can see we've got a marker on there, and we can give it a timestamp of when it occurs. So let's just take that thing and put it there like that. And you can see the center of this diamond lines up with whatever that time was. And in fact, for sort of convenience, we can repeat the time and everything is still tickety-boo. So what sort of things do I want as a marker? Well, I think, for example, it would be good to know when DB items test as a class loaded. So if we put a companion object in here, in it, when that's run, we know the class has been loaded, and that will only happen once. So we'd want to add a marker. For now, let's just do println, and we'll say DB items tests loaded at $instant now. Let's rerun that. And now manually, we can go and find that thing, DB items tests loaded at. So we've got that thing. Let's go back into our Mermaid. And let's pretend that we had an event which was DB items tests loaded, which was a milestone at that time. So you can see, in fact, that happened very quickly, but there was still a gap. So if loading the class isn't the problem, we're going to want to do this for different checkpoints in our test runs. So we don't want to hand edit our diagram. We want a way of adding to it from our code. Also note that we don't really want it here outside DB items test loaded. We want it within the DB items test, so that if the DB items test is running and we log an event, we want that to appear within there. So really we want that kind of like that, I suppose. So that's our mission for today. How are we going to go about it? Here's our timing extension again, and you can see this is where we store state. So when execution starts, we squirrel it away, and when it ends, we squirrel it away. There's a problem though, which is that we don't instantiate this timing extension. JUnit does that for us. So if we're going to affect the state of this thing, we're going to need to get hold of it in our DB items test somehow. What we actually want is something like timing extension as a static, go to its companion object and say something like event. And I guess an event will probably have a name and a time. So let's make that happen. What we want is timing extensions companion event. Yes, I think that would be a good place. So this is the name, and that's the now, and that's not an instant question mark, it's an instant. And I think I'm going to take that companion object and move it to the top. Now then, a traditional way of getting hold of the current timing extension, or the only one, would be to say that there is some instance, let's put it in here, so that's val instance, which is a nullable timing extension, and then the constructor of timing extension, when it's built, we set the instance. So we'd say instance equals this, and that should of course be a var. Now then, this will only work if there's only one timing extension, so before we do this we should check if instance is not equal null, then we're going to say error, another timing extension exists. And with that in there, we can run the test and check that that assumption is true. Oh, but our tests are failing because DB items tests, we're doing that thing. Well, let's go forward from there and let's say, what should timing extension do in its static event? Well, I think it should go to the instance and say, I've got an event for you, and that will have a name, and that doesn't yet exist. So we're going to create timing extension event, which for now will do nothing in but get the test to pass. Does that run? Well, not quite, because the instance may not have been set. So somebody may come along and say event on timing extension statically before JUnit has created one. So we're going to say that would be an error. No timing extension exists. Is that okay? Oh, we're still getting not yet implemented. Where's that? Oh, we left that in. Idiot. Take that away, run that again. And now we're good. From this we learned that JUnit has created the timing extension before it's loaded the test classes. So that's handy for us. Right then, what to do an event? Let's take it and put it down here. And in keeping with these other ones, I think maybe all we'll do for now is to say, let's have event times is a concurrent hash map of a string now. And then in here we can say event times at name is now. Just check that doesn't break anything. And it's good. But now we have the problem that we want our little diamond shape here inside DB items tests. So we need to know which container, which of these bars we're in when we raise an event. If in this execution started, we remembered the test identifier, then we know what it was when we raised an event, providing the lifecycle works that way. Let's find out, shall we, by saying here, this is current test identifier equals test identifier. And then in here, we're going to say current test identifier equals null. And I'm going to say, give me a property for that. And that's going to be nullable, but not late in it. It's just going to be var and set to null to start with. Now, if we had a test event class instead of this string, let's call that test event. It looks like I've got one of those, but I think in a completely different context. So let's not import that. And then here we can say this wants to be test event given the current test identifier and the name and now. And let's build ourselves, no, I do not want to import that. So we're just going to build ourselves a new class. Doesn't seem to be any way of creating a class at this point. So just go down the bottom and create ourselves a data class test event. Thank you very much. Come back to that. Go back up to this error and say add parameters to the test event. That is splendid. Thank you. Don't know what our error is now. Test event, that seems plausible, although I will just lay it out while I'm here. Events name equals test event. Oh, I'm an idiot. Given that we've put the time into the event, I think maybe these events should actually be a mapping between the test identifier that's the parent and the test event, because that will let us look up the children. So this will be event times current test identifier is test event. That's a fantastic error message. Type variable k found test identifier question mark. I suppose what it's saying is that my current test identifier may be null. I suppose we can deal with that there. But the problem with that is it will only allow one unparented test event. So I think probably the same thing to do at this point is to say we'll pull the current test identifier out and then we'll say if current equals null, then I'd like to know about that. So let's just say error. And in this case it will be no current test identifier. Otherwise, now we can go in here and say current. Oh, but again, I'm being an idiot because this will only allow one event per parent. So that's not good for us either. Let's just make this a concurrent hash map of test event to test event. That will effectively be a set. So now we can build the test event. And we can say event times test event equals test event. Now, given that this allows no current test identifier, that should be safe. We don't need to do this. And that should at least run. Phew. Okay then, if you can hear the change in my voice, it's because I gave up fighting the sore throat yesterday. I think, to be honest, it's winning today, but let's push on through. I think we've now got the information we need to display on this chart. We're just not displaying it yet. So let's go back to timing extension, and we're generating the Gantt chart here from the stats, which is a list of test stats. Okay. So I think we could add into our test stats any events that were associated with this test identifier. So let's add events in here as a val, which is a list of test event. And then we need that here. So as with here, where we had grouped by parent, let's get events grouped by parent. So that's val events grouped by parent is our event times keys grouped by, not that thing. I think we can just go to the test identifier. And now, once we've built the child stats, we can also find child events. Is events grouped by parent, given the test identifier. We don't need to sort, I don't think. But if there aren't any, we want an empty list. And then we'll put that into here. Again, we can run just to check that nothing blows up. And it doesn't. And now let's return to our generate Mermaid Gantt chart and say in here, this is where we're putting out the child tasks. So I think before we do that, let's go to the test stats, go to its events. And for each of those, we have an event, and we'll go to our builder, and we will, as before, we'll append a line. And what should that line look like? Well, we want the indent, although it only makes sense to humans, it turns out. We want the event name, like that. We want a colon, we want to say that it's a milestone. And the start time, we want to be the events now. And the magic comma at the end to make everything work properly. I think there's half a chance that will work. Let's have a go. Have a look at the chart. And yes, we have our milestone. Brilliant. After the milestone, though, we have this big gap. And that shows that this gap between the start here and here isn't DB items, the class loading. It's something else. So let's go and add some events to the test. Now, I think it'd be interesting to know when the DB items tests have been constructed. We could put an init in here, could we? And there we could say timing extension event DB items tests constructor. And to make things a little bit easier, I think I'm just going to default that instance now. So I'll take it out of there. Go back to our timing extension. The static one will gain equals instant now. Let's try running that. Oh, missed a thing. What happened there? Instant now. Oh, the AI added the return type. Not very helpful. Try again. Right then, let's go and have a look at our diagram. And there we can see it. We've got a constructor called there, then a big gap, then another constructor called there, and that's interesting. I would have expected a constructor call before every one of these tests, because the JUnit lifecycle is that a new instance of DB items tests is created for each test method that we call. So there being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there should be 10 constructor calls. So we've lost some somewhere. Can we see them anywhere else? No, okay. Okay, I'll spare you the debugging. The issue is that we're setting this current test identifier to be null here in execution finished, but really we want to be replacing it in some sort of way with the previous one, because these execution started and execution finishes formed a tree. So I think what we really want is something called, let's call it test tree or test path, and that needs to be a list of some sort of test identifiers. Now, I think the easiest thing to do there is to make that a concurrent linked deck, because we're going to want to push and pop from it. So it's going to be a concurrent linked deck of test identifier, and then the current test identifier, when we have a name, is going to be peeking the top of that. So it's going to be test path dot peak. That's the top item on the stack. And then when we start an execution, we're going to say test path dot push this test identifier. And when we finish an execution, we're going to say test path dot pop. I must say that I'm playing a bit fast and loose with these concurrent linked decks and concurrent hash maps and so on. As this isn't vital production code, I haven't really analysed what is safe and what isn't. I'm just hoping that if something goes wrong, it will be obvious. Anyway, let's run that and look at our test run. Oh, and there we have it now, a bunch of constructor calls. They're not obviously in the right place, but I think that's because we are showing all the events inside a container first of all, rather than mixed in amongst the other test stats. So let's go and fix that. This is where we add the lines. Here's the events and here's the children. And yes, you can see that we're doing all the events first. What we're going to need to do is combine the events and the children, order them and then put them out. Now that's going to be a bit tedious because our events and our test stats are just completely different types. To remind ourselves, here they are. We've got test stats and test event. I know inheritance is unfashionable, but if we were to just have an interface that was, say, timed, that had a property that was start, which is an instant, then we could make this timed as it does have a start, although that would be override. And test event we could make timed by making now into start, override that, and make this timed. Now if we go back, and if we combine all of our test stats, we say that's test stats dot events plus test stats children, and we ask the type of that thing. If we're right, it will be a list of timed. Splendid. So now we can say take that thing and sort it by it start. Now we need to iterate through all things for each, and this is a thing. Note that if I don't know a name for a thing, or if it's just thing, then I tend to give it a bad name so that sooner or later I'm forced to give it a good one. Okay, so for each thing, well, we may not be able to add task to chart because it may be an event. So in here we can say when thing is a test stats, then we can do the add task to chart. When it is a test event, then we'll do the thing that we were doing for test events, which it looks like that, where this is thing and this is thing. And actually we don't have to have an else because this isn't an expression, it's a statement. I'm going to put one in anyway just to remind us. So we say else error unexpected type of thing. So if we're right, that will take care of that one. And I think we could probably just inline that, drop that there, format, and run. Let's have a look. Oh, and there we are. We have the constructor run, and then the test, and then another constructor run, and then that test, and so on and so on. That's rather pleasing. Now we've still got this long wait between the first DB items test constructor and the first test running, but we don't have a similar wait for the other tests. That's a bit suspicious. I think what I'm going to do is I'm going to put another one in here. I'm going to copy that and put it after we've created the DB items. So I'm going to call this constructor 2 and this one constructor 1. Let's have a look. Aha! So that allows us to see then that it's in fact the first call to creating a DB items from the test DSL context that's taking a lot of time. We'll have a look at why in more detail in the next episode, because I have another couple of loose ends I want to tie up. One is knowing whether or not the before eaches are part of our test run or not. So I think I'm going to duplicate that and put that in here. And then this is going to be in before each. And then if we run that, we can see that the in before each is part of this test run. So it appears as an event as part of this test, which is returns empty stock list, as part of this test. The constructor calls, however, the ones that create an instance of the test to be used by the test, are outside this test run, which is a little strange to me. I've learned something about JUnit's lifecycle. Okay then, we're very nearly done. I think there's just one tedious issue left, which is that this is the version of the test that takes 1.7 seconds, and it takes that time because each one of these tests is run serially, one after the other. There's only one thread. So you see, boom, 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 boom. It's a continuous line all the way down to the right. That's because we changed this to be false. If I change it to be true and rerun, you can see that things have gone really quite haywire. We've got these events for DB items test constructor as part of the conjured aged brie updating tests, and so on. Why is that? Well, looking back in timing extension, the issue here is that execution started and execution finished are being run on multiple threads, and they are pushing and popping from this test path, but there's only one of it, and so each thread is fighting over it. What we really want, I think, is a test path for each thread. And at least on the JVM, we can do that with a ThreadLocal. So instead of having a single concurrent linked deck, we want a ThreadLocal containing a concurrent linked deck of test identifier. And if you have one of those, then each thread will have its own concurrent linked deck. Now that leaves the problem of how to create this test path, because we'll have a new one of these for every ThreadLocal. But we can finesse that with ThreadLocal dot with initial, and we put into there the supplier, the thing that creates the thing that's going to be inside the ThreadLocal every time a new thread comes along. So in fact, we can take that code out of there. A supplier can just be a lambda, and we put that into there like that. And I think then we can take that out. Now then, we can't treat a ThreadLocal just as the thing inside it. We have to say testPath.get and then peek. And in here, we have to say testPath.get in order to find the one for this particular thread. And the same in here. Shall we try it? Okay then, so now we have our things run in parallel. Standard updating test is being run in parallel with add items test is being run in parallel with DB items tests. But all of our events are correctly assigned to the paths inside DB items tests. So at first glance, at least, I think that's done the job. I'm not sure I'd bet a day's pay that it will always work, in particular if we allowed the individual tests inside a class to run in parallel. But the nice thing about this sort of engineering is we only have to get working the things that we need. On the subject of short-term hacks, I think in timing extension, I needed a concurrent set in here of event times, and I ended up with a concurrent hash map of test event. I think in fact I could just use a concurrent linked queue, so I don't think I need to take off both ends of test event. And then in here, instead of saying event times at test event, we just say event times dot add test event, which allows us to inline that. And that should lead to an error somewhere else. Where is it? Here we are. Instead of the keys, we can just take the event times, which is a concurrent linked queue. That isn't actually a list, but I think it's an iterable, and I think we have grouped by on iterable. We do. Let's have a look. Okay, back to our diagram, and it looks fine, albeit with a gaping chasm here of why creating the first DB items is so slow. But now I think we have some tools to investigate that. One of the great things about being a computer programmer is that we can build these tools ourselves, and it's kind of satisfying because we can just get on with them rather than engineering them in the same way as we had to do production code. And there's certain joy in being your own customer for the tools that you write. Well, I hope you've enjoyed that. Please subscribe if you want to see more of this sort of thing. My workshop at Kotlin Conf in May is unaccountably not yet sold out, so if you're going to Copenhagen, please consider that. And finally, if you read the book that I wrote in that price, called Java to Kotlin Refactoring Guidebook, we'd very much appreciate it if you would leave a review, either on Goodreads or on Amazon. Thanks for watching.